Hello, my name is Alejandro and I'm going to make a presentation on my research practice on Universidad EAFIT. Its name is Urban Land Use Classifier based on open data, and I am currently working with the RISE group, which is the Research in Spatial Economics group. So these are my tutors: Juan Carlos Duque, he's the director of the RISE group. Jairo Alejandro Gomez, he is a senior researcher, and Jorge Eduardo Patiño, he is also a senior researcher, both of them of the RISE group. So the problem definition we have on this research practice is that 81% of Latin America's population, they live in urban areas, and this pattern may turn to grow. So we need to find new sustainable ways to grant that this development of people going to urban areas, it's able to grow in a sustainable and a good way. So we want the cities to develop in a good way and not to collapse. And land use maps, they may help on this problem. Because they contribute on monitoring some development patterns, even managing natural resources. So land use maps are pretty useful on this problem here. But it is common to find in cities in developing countries like Colombia that do not have a land use map, or the map they have is updated. So they may have a map from 20 years ago, 15 years ago, maybe 10 years ago, and that it's capable of being pretty outdated. So having this creates a gap between the information that is reported and the actual use of the zone. Also, drawing a new map is a pretty long process that requires surveys, local knowledge, and money. And these resources may not be available for every city in developing countries. We can see in the image how the land use on the metro area of Montreal changed. It is a pretty high time frame, but anyway, you can see how the land use maps can change. So our main objective is to design a low-cost model that is capable of creating maps of the current urban land use of a city. We want to separate on 5 different categories, which is residential, commercial, industrial, mixed, and institutional. So mixed, it's like its name shows, it's a mixed zone between residential and commercial. It's like places where you can find residential zones on top of commercial zones, or maybe a store and a bunch of houses and everything. And institutional, it's mainly government zones, but we can also find private zones like private schools or private hospitals. I mean, we want to differentiate those zones, and we're calling them institutional. So this research is important because it can give a first estimation of the current use of the land use of a city. So we may have 2 possibilities here. If the city doesn't have a land use map, then we can have the first approach. And if the city already has a land use map and maybe it is outdated, we can make a comparison here and see if it is pretty outdated or is pretty good. So the information we're going to use is data from Medellin, Colombia, OpenStreetMaps, and satellite images that are open access. So we're going to start talking about the progress here. So it is pretty important to remember this regarding the data we use. So on the right we can see a picture of Medellin, and I made a zoom on the top of the picture to show that we work with pixels. So we currently give each pixel a land use zone, and we say if it is either residential, commercial, etc. It is important to note that each of those squares or pixels are 50 meters and on the bottom and 50 meters on the side. Okay, so the progress we made is that we included a bunch of new variables here from an orthophoto satellite image taken from the Medellin webpage, medellin.gov.co, using FETEX, which is an available library that give us these variables. So we can find the mean of the pixels. So we have the square I showed on the previous image, the previous slide. So we get the satellite image and get the mean of all the pixels that are inside of that square. We also get the variance, the mode, the standard deviation, and much more variables. And that is even for all the bands of the satellite image, which has about 4 bands. So we added a lot of new variables here. We're talking about more than 20 or more than 30 variables. We also added another variable regarding the main streets from Medellin. So for each square, we found the minimum distance to one of those streets and saved it. The streets were taken from OpenStreetMaps. So we had an increase in the performance. The F1 metric was increased in the random forest from 0.49 to 0.72. It's a pretty big increase, so we're happy about that. And the extra trees was increased from 0.46 to 0.67. On the previous report, we also tested the multi-layer perceptron, MLP. However, we removed it this time because it takes a lot of time to train, and since we are adding a lot of variables with the FETEX library, we prefer to work with the faster models, and they were giving pretty much the same F1s. So after that increase of performance, we made a comparison of the previous model, of the model without those main streets information, and also some information about the metro stations, the minimum distance from each square to one of the stations. And we saw that there wasn't a pretty big increase. So the F1s are pretty close, and we want to keep the model simple. So at the moment, we want to remove those variables. The less variables we can use without sacrificing a lot of performance, that's the best for us. And here's a picture of the current performance of the model. So it is important to show that we trained with half of the polygons and tested with the other half. So that's why the middle and the right pictures, they look a bit blurry. But this is because all those white spaces were the training set, and the colored squares are the training set. The shapes are pretty similar, and we're happy about that. And now the challenges we're currently facing. So looking and finding new variables that suit those small polygons it's pretty hard. We thought about some street information regarding the shape of the streets and everything, but since we have pretty small pixels, it doesn't make sense because most of them doesn't even have a street on top of them. We want to increasing the model's performance is pretty hard too, and the main challenge here is that the model works in different cities. So we're working on that. We want that the model is able to work on different cities such as Cali, Manizales, Valledupar, etc. And the future work we have is that we want to increase the model's performance, hopefully to 0.8. Add new variables, maybe add the MLP again, and include the mixed category. Here are the references, and thank you. Feel free to ask any questions.